There is something beating in the void, a rhythm so precise, so impossibly regular, that when NASA's instruments first detected it, scientists refused to believe their own data. They checked the equipment, they recalibrated the sensors, they waited for the error to reveal itself. But the pulse continued, unwavering, relentless, a cosmic heartbeat from a place where nothing should be alive. This signal violates our understanding of physics. It comes from a region of space that should be silent, dead, frozen in the eternal darkness between galaxies. Yet something there is calling out, and we have no explanation for what it might be. Before we journey deeper into this mystery, if you find yourself captivated by the unknown, if the cosmos pulls at something deep within you, join our community of cosmic explorers. A simple tap on the like button helps this story reach others who hunger for the universe's secrets. Share this with someone who dares to question reality. And subscribe to BrightBoundX, because we're just beginning to uncover the strange truth hidden in the darkness between stars. Now, let us descend into the mystery together. The discovery happened on an ordinary Tuesday morning at NASA's Deep Space Network facility in Goldstone, California. Dr. Elena Vasquez was reviewing routine data from the XMM Northern Space Telescope, a European spacecraft designed to detect X-rays from the most violent phenomena in the universe. She expected the usual cosmic noise, the random flickers of distant galaxies, the occasional burst from a supernova remnant. Instead, her screen showed something that made her blood run cold. A pattern, not just any pattern, but a pulse so regular it could have been a metronome, every 3.2 seconds. Exactly, not approximately, not within a margin of error, exactly 3.2 seconds. In astronomy, nothing behaves with this kind of precision. Stars flicker, pulses spin down over time, even atomic clocks drift. But this signal showed no variation. Zero. It was as if someone had placed a cosmic timer in the depths of space and walked away, leaving it to tick for eternity. The signal originated from a region designated as Coordinate Sector G07 for O+6620, located approximately 250 million light-years from Earth. This wasn't some nearby star or familiar cosmic object. This was deep space, the territory of galaxy clusters and dark matter, a place where individual stars blur into smears of light, and the universe reveals its largest structures. Dr. Vasquez immediately contacted a colleague, Dr. James Chan, an astrophysicist specializing in transient phenomena. When he saw the data, his first response was skepticism. Instrumentation error, he suggested. Perhaps interference from Earth-based signals, radio frequency pollution from satellites or ground stations. They spent the next 72 hours eliminating every possible source of contamination. They checked whether the pulse aligned with any known satellite orbits. It didn't. They compared it against every catalog pulsar in that region of sky. None matches. They searched for patterns in the telescope's own mechanical operations, thinking perhaps a mirror was vibrating or a sensor was malfunctioning. Everything checked out perfectly. The equipment was functioning normally, which meant the impossible was true. The pulse was real. It was coming from deep space, and it shouldn't exist. Word spread quickly through the astronomical community. Within a week, 3 other observatories confirmed the signal. The Chandra X-ray Observatory picked it up. The Fermi Gamma Ray Space Telescope detected it. Even ground-based radio telescopes found the corresponding rhythm in radio wavelengths. This wasn't a glitch. This was a genuine cosmic phenomenon, broadcasting across multiple bands of the electromagnetic spectrum. The universe was sending us a message, and we had no idea what language it spoke. The scientific community fractured into competing theories almost immediately. The first and most conservative explanation suggested a previously unknown type of pulsar, pulsars and neutron stars, the collapsed cores of massive stars that spin at incredible speeds, beaming radiation from their magnetic poles like cosmic lighthouses. We've known about pulsars since 1967. When Jocelyn Bell Burnell discovered the first one and briefly wondered if she detected an alien signal. But this pulse was different. Pulses slow down. The laws of physics demanded, as they radiate energy, they lose angular momentum. Their rotation rate decreases. It's subtle, sometimes taking millions of years to notice, but it always happens. Always. Except this pulse showed no slowdown whatsoever. Observations spanning 6 months revealed identical timing down to the nanosecond. Dr. Chan ran simulations using every known model of pulsar behavior. He adjusted for magnetic field decay. He factored in accretion from companion stars. He even considered exotic scenarios involving quark stars and strange matter. Nothing produced a pulse this stable. The math simply refused to cooperate. A pulsar this regular would require a mechanism to constantly replenish its rotational energy. Something continuously feeding it power. But the region around the source appeared empty. No companion star. No accretion disk. No visible matter at all. Just the pulse beating in darkness. The second theory ventured into more exotic territory. Perhaps this wasn't a pulsar at all, but something called a magnetar experiencing an unprecedented stable oscillation. Magnetars are neutron stars with magnetic fields a quadrillion times stronger than Earth's, powerful enough to strip atoms apart at a distance of 1,000 kilometers. They occasionally produce bursts of X-rays and gamma rays during starquakes, when their crusts crack under magnetic stress. But again, the stability problem emerged. Magnetar oscillations are violent, chaotic, and short-lived. They don't maintain steady rhythms for months. They erupt, decay, and vanish. This pulse had been detected for over 8 months now, with no sign of weakening or changing. Dr. Yuki Tanaka from the Tokyo Observatory proposed a different approach. What if we're not looking at a single object, but a binary system locked in perfect synchronization? 2 objects orbiting each other at precisely the right distance and speed to produce a regular pulse through gravitational lensing or eclipsing. The mathematics were elegant. 2 neutron stars, or black holes, bound by gravity, could theoretically create such a pattern. But when twins calculated the required parameters, the solution seemed impossibly fine-tuned. The objects would need to be in an orbit so precise that the slightest perturbation would destroy the pattern. No known mechanism could establish such perfect conditions, let alone maintain them. It was like finding the pendulum swinging in perfect unison after being randomly thrown into motion. Technically possible, but vanishingly unlikely. Then came the theory that made headlines around the world, the one that scientists whispered about in hallways but hesitated to publish. What if the pulse was artificial? The idea seemed absurd, the stuff of science fiction. But the data kept pointing in that direction. The pulse was too regular, too precise, too persistent. In nature, chaos rules. Entropy increases. Systems decay. Yet here was something that appeared engineered, maintained, deliberate. SETI researchers, scientists dedicated to the search for extraterrestrial intelligence, took immediate interest. They'd spent decades listening for signals that might indicate alien technology, always coming up empty. Now, without even trying, astronomers had stumbled upon something that defied natural explanation. Dr. Amara Johnson from the SETI Institute ran the pulse through every algorithm designed to detect non-random patterns. She looked for mathematical relationships, prime numbers, geometric sequences, anything that might indicate intentional design. The results were frustratingly ambiguous. The pulse itself was simple, just a regular beat, but its stability suggested something maintaining it, perhaps even controlling it. If this was a beacon, it was unlike any transmitter humans had ever built. Our technology drifts. Our clocks need correction. Our satellites require constant adjustment. This signal showed none of those imperfections. It was as if whatever created it existed outside the normal flow of time, untouched by entropy. The implications were staggering. A civilization capable of maintaining such a signal would command technology we couldn't begin to comprehend. As observations continued, stranger details emerged. The pulse didn't just maintain its rhythm, it seemed to interact with its environment in ways that defied explanation. When a distant galaxy passed in front of the source due to our viewing angle, astronomers expected the signal to be absorbed or distorted. Instead, it punched through unchanged, as if the intervening matter didn't exist. Light from normal cosmic sources bends around massive objects due to gravity. It scatters through dust, it redshifts as space expands. But this pulse ignored those rules. It arrived at Earth with the same strength and timing regardless of what lay between us and the source. Dr. Vasquez proposed an unsettling possibility. What if the pulse wasn't traveling through space at all? What if it was being projected directly to a location through some mechanism we didn't understand? Quantum entanglement allows information to correlate across distances instantaneously, though it can transmit usable signals faster than light. But what if there were loopholes in physics we hadn't discovered? What if advanced technology could manipulate space-time itself, creating channels through which signals could propagate without interference? The idea sounded like fantasy, but so did radio waves before Maxwell's equations, and quantum mechanics before Planck's constant. Perhaps we were witnessing something equally revolutionary, a phenomenon that would rewrite our understanding of reality itself. The most disturbing revelation came 13 months after the initial discovery. The pulse changed, not in timing, but in structure. The regular beat remained, but now it carried modulation, subtle variations in intensity that formed a secondary pattern. Researchers initially thought this might be interference or instrumental artifacts, but the pattern repeated every 97 pulses, far too specific to be random noise. Dr. Chan assembled a team to analyze the modulation. They found something extraordinary. The intensity variations corresponded to prime numbers: 2, 3, 5, 7, 11, 30. The sequence continued up to 973 before looping back to the beginning. Prime numbers, the fundamental building blocks of mathematics. The one concept that any technological civilization would inevitably discover. This wasn't just a pulse anymore. It was a message, a demonstration of intelligence, a proof that whatever created this signal understood mathematics, logic, reason. The universe had given us a cosmic phone call, and someone was on the other end. The scientific world erupted. Emergency symposiums convened. Governments demanded briefings. Religious leaders offered interpretations. Philosophers debated implications. Humanity stood at a threshold it had imagined for centuries, but never truly believed it would cross. We were not alone. Somewhere in the darkness between galaxies, something was reaching out. And now, finally, we had answered.